Hey, I'm just gonna go over all the stuff you're gonna need to know in order to do homework 4. So the first thing you're gonna need to know is, what is microprogramming? To me, microprogramming is kind of like another version of Vesp, and I say that because it has an opcode and an operand. The only difference is that microprogramming has an opcode of only 2 bits long and an operand of 14 bits long. And because the opcode is only 2 bits long, there is only 4 possible instructions that it could do. The first 2 are the most important. The last 2, not so important. Like, you could do the homework without them, so I'm not going to go over these 2 at all. I'm going to focus on these 2, and that should be enough. So let's get straight to it. The first opcode is 00 for the data transfer micro instruction. So this is how it works. You're going to have an ALU, an A bus, and a B bus, and an O bus. So let's say you want to do something like A plus 1, then you would load A into the A bus and 1 into the B bus and add it using the ALU. And the result is going to be stored inside of the not B bus. The result is going to be stored inside of the O bus temporarily. The step after that is, how do you interpret the result? Are you going to look at the O bus and just store it somewhere else? Or are you going to look at the O bus and be like, oh, hey, the O bus is equal to 1, I should read. Or, hey, the O bus is equal to 0, I shouldn't read. And that is pretty much how this opcode will work. So let's do some example. Start off with something easy like A is equal to 2. So to do A is equal to 2, the first thing I want to do is write down the opcode of 00 for data transfer. I'm going to load 1 into the A bus and 1 into the B bus and add them up. So 100, 011, and add them up. So right now is 1, 1, add them up, so 1 plus 1 is 2. And store the result into A. So this whole line of code is just saying A is equal to 1 plus 1, which is equal to 2. And once you have your binary code, all you have to do to put inside of Vesp is convert it to hex. So just copy and paste it inside of your translating program, and you get hex of 2320. And the question you might have is, how do you test your code? Well, I would show you it, but it's like really tedious, and I don't want to go over it in this video. So for now, just like learn how to do the microprogramming, like how to write it first, and worry about testing it later. Anyway, let's do a harder example. So let's do A is equal to 2A plus 2B. Now this one is really tricky, because the problem is, if you look at the function that it could do, like all of the math calculation, most of it could only be done with the value that is stored inside of the A bus. See those? Most of these could only be done on the A bus. So my first step would be to store my original A value inside of another variable, and I'm gonna pick H. Excuse me. So just like A or B or IX, H is just like another variable that you could store inside. So this line of code is going to be me trying to get H is equal to my original A value. So load into A bus the value A right here. Then it doesn't matter what B bus is, so I'm just going to put 0 for it. Then I'm going to let O bus equal to A. Then store the result inside of H. So 1, 1, 1, 1. And this whole line right here is just saying H is equal to A. So now H is holding my original A value. Now that I know my original A value is safe and can't be altered, I'm going to try to get to B. So I want to get my B value inside of my A bus so that I could shift it. And the problem here is that you can't load B into the A bus at all. So I'm going to have to get A to be equal to B so that I could bring B over to the A bus and shift it. So that's what I'm going to do. So this line is just going to be me trying to get to B. So 0, 0. Doesn't matter what the A bus is. B bus is equal to B. O bus is equal to B. And store the result inside of A. So now my original A value have been overridden and A is now equal to B. And since now A is equal to B, I could finally load it into my A bus so that I could shift it. So 0, 0, 1. Doesn't matter what the B bus is. Now I could shift it. So right now, the my A bus is containing B, then I shift it left by 1. So now I have 2B, and I'm going to store the result into B. So 0, 1, 1, 0. And this is what this line's saying. So now that I have 2B, I'm going to try to get 2A. So 0, 0. Oh yeah, my original A value is stored inside of H right now. So I'm going to try to get my A to be stored back inside of my A value. I mean, I'm going to try to get H to be stored inside of my A value now. So to do that, I'm going to do 0, 0. Doesn't matter what A bus is. I'm going to load H into my B bus. And I'm going to get my O bus to be equal to my B bus. So my O bus is now equal to H. And I'm going to store that back into A. So that's just saying A is equal to H. And because H is holding my original A value, I'm just saying now A is equal to my original A value. Now I could shift it. So 0, 0. I'm going to load A into my A bus. Doesn't matter what B is. Then I'm going to shift it. So 0, 1, 1, 1. And load the result inside of my A. So A is equal to 2A is what this line's saying. Now that I have 2A and 2B, I'm going to add them up. So 0, 0. So this is just me saying A is equal to 2A plus 2B. So 0, 0. Load A into my A bus. B into my B bus. Add them up. 0, 0. and store the result into A, which is 0, 0, 0, 0. And this whole line of code is just saying this. A is equal to 2A plus 2B. And now that this is done, all you have to do is copy and paste this and yeah, just copy and paste this and convert it all into hex. I'm not going to do that because it takes too long. Oh yeah, one more thing. At the end of all of your code, you need to have ret set equal to 1. And the code for it is always the same. So just copy and paste this. And what ret set equal to 1 means is this is like the microprogramming version of halt. So every time you finish your code, always have OX 0317. So this is just saying halt. And you always have to have this at the end of every code or you're gonna crash. There you go. Okay. Now this should be enough for you to finish part B of problem 1. Actually, no, I mean part A of problem 1. Okay. So for part B, you're gonna need to know how to read and write. So these two code down here is what you're gonna need to know. And they are pretty confusing to learn or confusing for me to teach. And I'll try my best to explain it. So let's say you want to do something like vesp.mem of 1 is equal to vesp.mem of 2. And to shorten it, I'm just going to delete the vesp part. And I'm just going to say mem because I like this way better. It's like easier to read. So like I said, you're going to need these two instructions down here. And how they work is when you have this opcode, well, not opcode, when you have this operand value, what it does is it's going to look at your obus value. If the first bit of your obus is equal to 1, then this command is going to run. This is going to execute. If the first bit of your obus is equal to 0, then this will not execute. It will not run at all. And the whole line of code will be pretty much redundant. Okay? So to use this code, like to read or write, all you have to do is load 1 into your obus and do that however you want and run this code, and it's gonna set the MDR equal to memory of MAR. Okay. Anyway, it's better to show you than just to talk about it. So 0, 0. I'm going to try to get this first. But to get this, first, I'm going to need to get my MAR to be equal to 2. Because if you look right here, read just says that MDR is equal to mem of MAR. Right here, you have mem of 2. So the MAR here should be equal to 2. So this line of code right here, I'm just going to try to get 2 to be stored inside of like any variable. So let's say load 1 and 2 A bus, load 1 and 2 the B bus, add them up, and store that inside of A. Actually, no, store that inside of the MAR. Zero, 1, 0, 1. There you go. So right now my MAR is equal to 2. And now I'm going to try to read. So I'm going to say 0, 0. A bus is equal to 1. It doesn't matter what B bus is. My whole goal right now is just to try to get the O bus to be equal to 1 because I want to read. And it will only read if O bus is equal to 1. So it's kind of like a secondary function, pretty much. And O bus is equal to A bus. Okay, so right now O bus is equal to 1. And I'm going to run this code right here, which is 1100. And because O bus is equal to 1, it's going to read. So this whole line of code is just saying MDR is equal to mem of MAR. And because up here my MAR is equal to 2, this line's pretty much going to say MDR is equal to mem of 2. So now my MDR is equal to mem of 2. So I have this now. So my goal now is to try to get this value over here. And you could see that the MAR of this is equal to 1. So now I'm going to try to get 1 to be loaded into, stored inside of my A or B value so that I could use it. So 0, 0. I'm going to store 1 inside of the A bus. So 1, 0, 0, 1, 0, 0. Doesn't matter what the B bus is. I'm going to say O bus is equal to A bus. So O bus is equal to 1 right now. And I'm going to store that result inside of my MAR. So 0, 1, 0, 1. Just saying MAR is equal to 1. And now I want to read. So the whole goal is just to try to get my O bus to be equal to 1. So this run right here is saying load 1 into the A bus, doesn't matter what B is. Let O bus equal to 1, or let O bus equal to the A bus, which is 1. And I'm going to write. So it will only write if O bus is equal to 1, and it is equal to 1, so it's going to write. So this whole line of code is just saying mem of MAR is equal to MDR. And because my MAR was previously equal to 1, that's just saying mem of 1 is equal to MDR. And previously, my MDR is equal to mem of 2, so this is just saying mem of 1 is equal to mem of 2. And that should cover part B of problem 1, I think. Yeah, it does. Okay. Oh yeah, last thing you want to do, ret set equal to 0. Ret set is equal to 1. And convert that to hex however you want. I'm not going to do that. It takes too much time. And yeah. Let's go over an example of the last problem of problem 1. Okay, so you're going to need the branch command. Okay. So let's do an example I have on my Word doc. So let's do is if A is equal to 0, A is equal to A plus B, else, let's comment that. Else A is equal to A minus B. So the first thing you need to do is have an if statement, like if A is equal to 0, jump. So let's go up here. Branch has an opcode of 0, 1, and branch is the micro instruction version of jump. So branch is pretty much jump. So 0, 1 for the opcode, and my condition for jumping is if A is equal to 0, so that would be 0, 0, 1. And I'm going to jump to some address. I don't know it, so I'm just going to put it X for now. And I'll go back to that later. So that's just saying jump. If A is equal to 0, jump to some address that I don't know. So underneath here, if I'm not jumping, then it's just going to continue to the next line of code. So that's pretty much my else statement, right? Because if this doesn't like jump down here, then it's just going to run this code over here. And that is going to be my A is equal to A minus B. So let's go back up here. This is going to be A is equal to A minus B. That's what I'm going to try to do on this line of code. So 0, 0, 0, 0, 1. A bus is equal to A. B bus is equal to B. Subtract them, 0, 1, 0, 0. So this A is equal to A minus B. And what I want to do is to halt. There you go. So if A is equal to 0, it's going to jump down here, whatever this line is. If it is not equal to 0, then it's going to run this part of the code and then halt. So if it's equal to 0, it's going to run A equal A plus B. So that's what I'm going to do on this line of code. So 0, 0, A, B, add them up, and store the result inside of A. And then I'm going to halt. Okay. So, yeah. So if A is equal to 0, it's going to jump to this line of code, whatever this address is. So let's say, for example, this is line 0, this is line 1, this is line 2, this is line 3, and this is line 4. So if A is equal to 0, I want to jump to address 3. 3 in binary is 1, 1. And because this part of the operand has to be 10 bits long, then I'm just going to fill the rest with zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is my opcode for the jump command. So if A is equal to 0, jump to address 3. And it's going to run this. Otherwise, it's just going to continue on and run this and halt. Okay. And again, convert this all to hexadecimal once you're done. So I'm just going to do the first line of code, which is 4403. And then continue on and halt your program. And that should finish part C of problem 1. And thanks for watching. I'll probably continue on problem 2 some other day. Yeah. Bye.